Hi everybody, and welcome. Today we're going to be talking about combining polynomials. So the three specific ways we're going to see in the video today are with addition, subtraction, and multiplication. So your goal after watching this video will be able to add, subtract, and multiply polynomial terms. The best way to think about this is to break it down into area, specifically for multiplication. So if you look at a complex shape for area, maybe something like the top one here, we would get something along the lines of like, and again, apologies, looks like my Apple Pencil is not cooperating today, but that's okay. For our top one here, and I'll do my best to draw this, and we'd have something like 3 here and 3 here to get that area of 9. Then for the bottom one, maybe this edge is 3 and then the bottom edge is 7. Now if we do that, we're going to be able to look at these as individual squares. So we'll see it's something like, this one right here gets us the 3 times 3 area of 9. And then we can also take a look at our bottom square there, the 3 times 7, to get us the area that we're looking for 21. So if we put these two things together, we combine them, we're going to see two separate shapes, and we add up to get a total area of that 9 plus 21 to get us an area of 30. Next, we're going to see the same thing for the bottom. So two different ways to look at this. You might see right away off the bat, like, oh, Mr. R, we can just combine our sides here. So maybe we can just take, our 4 plus 6 to get 10, and our 3 plus 5 to get a simple 8. To get an area of 80. But if we do like we did up top, and we take these things individually one at a time, breaking these up into smaller chunks, will we get that same answer of 80? So let's see, 4 times 3 gets us 12. This edge again is 4, times 5 is 20. We'll see this edge of 3 times 6 on the side is 18. And then we'll see an edge here of 5, and then that length there of 6 would get us an area of 30. So actually, if we look at this, it gets us to the same area of 80 both ways. And that's what's going to be useful today, is we're going to be able to break these things into smaller parts. That way when we're multiplying polynomials, we can think of it like area. We can break it into smaller parts and then add it up. And that makes it possible because sometimes, if we look at the bottom here, something like x plus 3, we can't put x and 3 together. Those aren't like terms. So in order to get the area of that box, that's why we're going to have to break it into smaller chunks. So our first one, length times width, is just x times x, or x squared. And our next one, length times width, is 3 times x, which is just 3x. So the area of this box is x squared plus 3x. And that's also the answer to the multiplication problem, x times x plus 3. And that's why the box method is particularly useful for multiplication. It sets us up to be successful, to be organized, and to have a conceptual understanding of why is x times x plus 3 going to give us that answer of x squared plus 3x. All right. So some definitions to start us off here. We are first going to be taking a look at like terms. And these are terms that we can add and subtract because they have the same variable and power. So for example, something like 2x plus 3x, the variable for both of these is x, and for both it's to the power of 1, so we are allowed to do 5x. But if we have something like 2x squared plus 3x cubed, what we're going to see is the variable and power for the first one is x squared, the variable and power for the second one is x to the third power. So these are not like terms. We are not allowed to add or subtract them. So that won't work. We can't do anything past this point. That's the simplest form. Whereas for the one on the left, again, 5x is the simplest form. Same variable, same power. We are allowed to add. And that's basically what this addition and subtraction turns into here, is we're just looking for what has the same variable and the same power. So very similar to fractions. We don't change the denominator when we add. Same thing with like terms. We are not changing the variables when we add. So 4s squared and 2s squared gets us 6s squared. We're not going to change that. We can look at our minus 3s and our positive 2s to get us negative 1s. And again, be careful, that's not a 3s, that's a negative 3s. So again, keep the signs with the numbers. And then our last step here, we have constants, so our 2 and our negative 7 will get us to an answer of negative 5. And that's the most simplified form. All right, it gets a little bit more difficult when we are looking at subtraction questions, like that third one. you can think of this in two ways. You can either distribute the negative and add, or you can take each of the terms one by one and make sure that you are subtracting the second term. So this turns into something with our a to the third power like terms. It's 2a to the third minus a to the third. For our next one, we have this negative 5a here and this negative 2a squared. Actually not like terms there, gotta be careful. We have to find a just to the a term, which is actually our positive 3a here. Okay, so good catch. Again, always remember to make sure that you're matching up not only the variable, but the power. It can be tempting to be like, oh, next one on the line is the one we combine. In that case, almost got me, but being careful. So negative 5a for our first one, and then minus the positive 3a. So again, can't forget, even though it's plus 3a, we're subtracting the total value there. Next one, negative 7 as our constant. We are subtracting the negative 7. So it's not just minus 7. Again, we're subtracting the minus 7. And then finally, the last term that we kind of have left over there from that second one is we are subtracting from nothing that minus 2a squared. But again, because we are subtracting it, we do need to make sure we have the negative as well outside of the parentheses. So one at a time, let's go through and let's put these together. So that's positive 2a squared. In green, that's actually going to cancel out to give us a 0. In yellow, we're looking at negative 8a. And then finally, in the red, we are going to have 1a to the third power. Now, just like we were doing in class together, let's make sure we put these in order of degree. So 1a cubed plus 2a squared minus 8a plus 0. We can just leave like that. All right, a final example, some baseline, just single term monomial multiplication on the bottom. We multiply our constants, so multiply 7 and negative 4 to get negative 28. And we also multiply the variables. So when we multiply or divide, we actually do change the variables. So here, we're going to have y to the 2 plus 5, or 7th power, okay? So when we multiply, we add the exponents. And we'll see an example on that next question. A quick reminder that is a to the first, and a second reminder that that is b to the first as well. So when we go through and add those, make sure that we are also adding it to that first power term. All right, so we're going to look at a little bit more multiplication, because if we're multiplying anything that's bigger than a monomial, it gets a little bit more difficult. And to do this, keep ourselves organized, we're going to use something called the box method. So the box method is an organization method for multiplying polynomials that uses area. So again, for example, we saw before that x times x plus 3 example. The way that we can go through and simplify this is, again, put those two lengths together on the top of your box. You can see what we're multiplying, and we put those together to finish. So if you've done something like FOIL before, you're used to probably distributing. The box method gets you to that same answer. It just keeps you a little bit more organized, and especially when things get bigger, it's going to be a really useful strategy. All right, so let's practice these, again, using the box method. So we have two terms on each side, which means that we have a 2 by 2, or a binomial box. On the top, we'll put our first term, so 2x and 5, and on the side, we'll put our second term, our 3x and our minus 7. And just like we started class with those conceptual examples, on the inside of our box, we're going to put our multiplication problems, our length times width problems. So again, 3 times 2x for the first one, 5 times 3x for the second one, and then 2x times negative 7. It looks like my Apple Pencil is giving me some problems, but we'll be all right. Yeah, apologies for that delay. I think we're back on track now. And then 5 times negative 7. So we get 6x to the second power. We'll get 15x. We'll get 14x. We'll get negative 35. Looking for some like terms here. 15x and 14x will actually come together nicely for us to give us a final answer of 6x squared plus 29x, again putting together those like terms, minus 35. So quick review of the box method there. That's going to help us out, especially when we get down to an example like a trinomial times a trinomial, or trinomial times a polynomial. There's 4 terms in that second one. It's going to be really hard to keep organized and not make a mistake if we don't have that box there to help us out. And a quick check here, always good to look back. It looks like my negative sign didn't get carried through for the 7, so we're going to have a minus 14x here. So correction for that first one will be a 1x term in the middle, 15 minus 14. So always good when you're done to take a look back through and make sure you didn't lose one of those negative signs or have it, again, maybe go away like it did for me there. So again, double checking there. Looks like we're in good shape for this one. And again, negatives, definitely want to be careful with them. And that's another advantage of the box method. It really helps with those negative terms to make sure that you have them in the correct order and to make sure that we're not dropping any of those signs. So to get us started for our next one, another binomial box, we're going to want to put x and minus 7 on one side, x and positive 5 on the other, and then go through and do the multiplication for each of our edges. And again, don't forget that negative 7, just like I did on that first one. A good example to learn from there. All right, so we'll go over these in class together. I know that there might be some questions, a little bit of a review. If we haven't seen it in a little bit, though, these can definitely be tricky ones to remember. So